So, hello, our team is Manjeta team, and today we are going to present analysis of temporary variables of land use land cover of Southeast Texas. And for this purpose, we have some data. Uh, our team member is me, Kevin Mistry, Rina Shrestha, Qazi Turukul Islam, and fourth one is Akayam Hussain. So basically, what is a land use land cover? Uh, so the land use is the just variables, landscape variables, and land cover is a ordinary characteristics as a vegetation and a man-made development which happen on a earth surface. Like there are so many variables like crops, water, wetland, built-up land area, and others. Uh, Land use land cover change with the help to take up the clear strategy of managing natural resources and monitoring environmental changing. So urban explanation has brought a serious losses of agricultural land and vegetation land cover. So the land use land cover data document how much of the region is covered by the forest, wetland, impervious surface, agriculture, and other land like water and some others. Okay, so our for this project, our study area is Southeast Texas. So this is our 14 county, and this is our study area. So in this project, we collect our data from the four websites. First of all, first one is MRLC, which is a multi-resources land characteristics, uh, and we get a Texas map from the this this website, Texas dot government, and other source of data is uh, ESRI, and the last one source is a census. Thank you. And now we are going for the coding part. Uh, so this is our topic name, temporal variable of the land use land cover, and our project objectives are distributed area of a land use variable of a Jefferson County. So we have a 14 county. We choose a Jefferson County for this project. Our second topic objective is the comparison of the land use variable of the Southeast Texas in 2016 and 2019. So, and our third question is the percentage of area of the five land use variable of the Southeast Texas, uh, which is included a water bodies, land and others. Uh, our fourth question is a change in a development land cover over the 18 years in Southeast Texas. And our fifth objective is a change in a forest area over 18 years in Southeast Texas.
Improved some libraries. First of all, we improved digital pan bro. See one of the things. This improved matplotlib
Matplotlib is PLT.
from OSGeo.
Import GDAL.
This project we need to some improved libraries. First of all, GDAL.
Yeah.
Is this same? Okay, sorry. So it's delete.
Yeah. Just
Now
start from the beginning.
It's okay. Mhm. For this project, we need to input some libraries. First of all, we import GDAL for geospatially data, especially raster data. Then we import matplotlib for plotting the map. Then import pandas spd. And then input pandas spd. Import geopandas for analysis of the shape file. We need to
Um, we uh, we want a plot Texas map. So first of all, we set a working directory for the Texas map county. We get a data from the texas.gov. So after getting the data for the read purpose, we use a GeoPandas library. So this is a map of for all county of Texas, and for the clipping, our area of interest is these 14 counties. For the clipping the data, we use GeoPandas pd.concat function. So this is a 14 county map of our area of interest. So after that, clipping the Texas county map to the Jefferson County. So for the plotting this Jefferson County, we use this code and we get a map of Jefferson. Okay, then our coordinate reference system of shapefile is 4326. Thank you. The further explained by the Kasi.
So now we are going to set our directory for our land is land cover data for 2019. We open our image file using GDAL library, that is gdal.open. Then to get the projection of our image file, we use a dot get projection, um, which is the function of GDAL library. So we can see that the projection of our image file is not similar to the projection of our save file. So we have to change the projection so that we can um, clip it with our save file. So to change the projection, we are using the GDAL library warp function. We are giving our data of 2019 as our input, and we are changing our projection to EPSG 4326. Then after changing the projection, we are going to clip it to our area of interest, which is Jefferson County. And then after clipping our data, we plot the data using plt.im. So this is the data of our land is land cover for 2019. Then after getting our area of interest, we created a function which will count the number of pixels in that data. If we know the value of our pixel intensities, then we created another function which will count the area. So we'll find the area by multiplying our count with the pixel size, which is 30 meter by 30 meter, and then we converted our square meter area into square miles and return the area. Then here we have counted the total area of our Jefferson County, which is 2031.06 square miles. Then after getting the total area, we are counting the percentage area of each class by dividing the area by total area of Jefferson and then multiplying it by calculate the pixel number of each class. So we separated 11 and 12 class into water, ice, and then we separated the developed land into one variable, and then barren land, and then forest. We separated the two similar classes into a variable forest, and for vegetation we added the shrubland, herbaceous, and planted. And For total water area, we added the wetland area and water ice area. Then we listed it in a group so that it will be easier to use to calculate all the areas at a time. Then after that we called the function we created to calculate the area of each class. So we can see that the areas are listed here. Then we use the percentage function we created to calculate the percentage of each class with respect to the total Jefferson County area. Then to plot the then now we are going to see the distribution area of each class in Jefferson County so that we can compare which variable has the highest area and which has the lowest area. To plot the bar graph, we used matplotlib function that is plt.bar. Label is our x-axis and area of Jefferson County is our y-axis. So we can see from the graph that the water area is highest in Jefferson County and forest area and barren land are the lowest. The water area is highest in Jefferson County because it lies near to the uh, uh, coastal area. So by plotting this bar, we can compare the land use variable areas of each county by using.
So we need our area of interest, that is Southeast Texas 14 county data as a TIFF file. So that's why we try to clip our data and using the GDAL, and we are using the function of gdal.wrap. So that's gdal.wrap and using the LULC county.tiff data in this, and we try to cut our data. That's why we are that's our path of the shape file of our county 14 county data, and we clip it, and we try to plot our projection here, and we use the plot.im show to projected our area of interest as a Southeast Texas TIFF file study area, and the plot.color lab for the color purpose. We have a different color coding over here. So calculate the pixel of each classes of set X. So pixel number. So we have different classes of the land use land crop variables. So we are going to calculate all of the classes pixel number. So that's for water and ice, wasteland, forest, planted vegetation, wetland, and water percentage area. All this, and from all the classes, we take only our five variables, which is water, uh, development area, and buried land, vegetation, and forage. And we're using the NumPy array as for this, and we take the four pixel number of our five variable classes, and the area of each class. We are going to calculate the area of each class of setx 2019. So for the area calculation, we are using the for loop, and we get the five variables area for our setx. So we are going to calculate the percentage of each class of setx for 2019 data. So again, we are using the for loop, and we get the percentage of our different land use variable. And we are using the same process as before we done for the Jefferson County and 2019 data. We use our change our working directory, and for data using the GDAL to open and reprojection the data, and then the main part is the change of the projection of the TIFF file. So
we have to convert the T file projection into EPSG 4326. So that's why we are using the function of that reprojection, and using the gdel.wrap and LULC 2016 file to transform the reprojection into EPSG 4326. So get the reprojection, and we get we have already transferred and reprojected our TIFF file into EPS 4326, and then clip and plot the LULC data for 2016 for to area of interest. Our area of interest include 14 country, and we are is using the same process as before we done it. So just using the function of gdel.wrap, then clip it to our county shapefile, and then convert it into our from total Texas clip file to ZX Texas clip file. So now we get the ZX Texas land use land data for 2016. So that's the projection of the land use land cover data for 2016, and we again calculate the pixel number of the each classes, and take the 5 variable that we are dealing with, and take and calculate the area of each classes for the 2016 ZX area of interest, and again we are try to calculate the percentage of the area. So then we are try to compare the area of each class between 2016 and 2019 with using the bar plot, and that's why we use a numpy array, and then set our year as 2016 and 2019, then x bar as a X bar, and that is a classification, and set the labels and the bar X bar Y bar and the title of this, and give the legend of here as a left corner, like, and set the and write the label as water, developed land, barren land, vegetation, forest, and show it as a graph plot. So from the comparison of the land use of variable for set x, so uh, we found that for 2016 and 2019 there is nothing change in the water body part, but there is slightly change in the development land and barren land and the vegetation. There's nothing change in these two variables, but there is slightly change in the forest area, which is a decrease from 2016, and all the data are in area square miles, and we are trying to calculate our settings or our area of interest data of in 2001 data. And again we are using the same procedure like before we did for 2019, and we try to change our projection into EPSG 4326, and try to calculate the area of interest variables, and just clip in the data from Texas map to Southeast Texas by using our county shapefile, and we get that same data file for 2001, and like we told before, that's the each class of setx 2001, and we take only 5 variables, and again calculate each class for setx 2001 data, and calculate the percentage of area for setx 2001 data, and we got this 5 variables data, and we are showing this data by using the pie chart. And we have already shown that in 2001 in our 14 counties, so in our 14 counties the biggest part is the forest area, and the second one is the developed area, and the red one is vegetations, and the blue one is 7.5%, which is water body area. So we are trying to compare the area of each class between 2001, 2016, and 2019, because we are trying to try to find out the changes over the past 18 or 19 years by using the bar plot. So comparing the land use of our five variables for set x, we get that in 2001, the developed area are uh, lower than the 2016 and 2019, and there is a some changes over the vegetation area, and we have seen this the forest area are increased than before 2001. So our forest area increased uh, in over the past 18 years, and our developed area also increased, but the vegetation and the water body are not seeing so much change, any kind of change in this part. So what is our query of the project? So first of all, our first query is distribution to find out the distributed area of five land use variables of Jefferson County. So in Jefferson County, so we take the TIFF file and just clipping into the Jefferson shapefile, and we get the map. And when we try to find out the area of the Jefferson County and compare, just distributed it, and we found that in Jefferson County, the water area in square miles are uh, very high than the developed area or the barren land or the forest, because this Jefferson County is located at the southeast Texas coastal area, so that's why the water body area is higher than the other county. So our next queries from is the comparison of five land use variables of set X in 2016 and 2019. So uh, we are trying to compare our set X whole 14 county, and we found that in 14 counties in last past 3 years, the developed land area are increasing and the forest area are slightly decreasing, because when the developed area increased, obviously the forest area will sometimes decrease. That is our second task, and second finding. And our third finding is to calculate the percentage of area five land use variables of set X. So in our pie chart, we get our in our pie chart we get our the percentage of land use for 2001. Like we get that the in SETEX the forest area is higher and the vegetation is lower, and the second most bigger part of the land use is the developed area, which is increasing day by day, as we seen in the part. And our fourth query is to calculate the change in developed land over the last 18 years in SETEX. So from our bar chart, we've seen that. So we've seen that in 2001, in SETEX, our developed area is nearly to the 2000 area square mile, and 2019 it will increase, and it will nearly to the 2500 square miles per square miles. So it increased a lot over the 18 years. So our fifth query is how much the change in the forest area over the last 18 years, because it's related to the deforestation. We try to find out how much the change of the last 18 years. So uh, from our data analysis we get it in 2000, from 2001 to 2016, the forest area increased a little bit, but compared to the 2016 to 2019, the forest area slightly decreased. So we can say that from 2001 to 2019, the overall forest area are increased. So that's our main goal, to analyze our Southeast Texas 14 county land use land cover data and find out some important queries like the land use variable for each county, and comparison for the recent past 3 years, or the percentage of the distribution of the land use variables of Southeast Texas. So from the distribution we can understand how much water body, how much cropland or the forest area are in the Southeast Texas land have, and what the change is, what the changes is done in the last piece, last past 18 years in Southeast Texas, like the changes of the development, which is related to the urbanization, and the changes in the forest area over the last 18 years. So by using the data, and so we can find there are a lot of change in our land use land cover data, and it helps to analyze our land use land cover and urbanization data for Southeast Texas. And uh, uh, using the Python to analyze the land use land cover and the data, and especially the geospatial data, helps a lot to easily find